In this video, I will present to you the first version of the mapping, localization, and object detection systems or modules for the Amazon Picking Challenge. To test them, you have to update your current repository, a local repository of Mercurial in your machine. In my machine is set up to working Rutgers Amazon Picking Challenge AG, so everything is here. And to run this empty membrane, you're going to need a Kinect and a machine with CUDA. After you have everything compiled, you're going to need to run this to set up the ROS in that directory, and then run this ROS launch that runs mapping, object detection, and also localization. Localization currently is made by the mapping system. So the mapping system is going to do mapping and localization as well. And you have a second system for object detection. In this launch, we're going to launch everything. It takes some time to start the whole system, in particular the object detection system. And to run this launch, we also need to run this program, and this program is necessary to change the configuration in the driver of Kinect. That's necessary. So why? Because the standard situation of Kinect, which is shown here, have the color and the depth information. These two channels are not aligned, so I have to align them in the driver. So by running this program, it's still starting, I'm going to change a parameter in the Kinect driver so that color and image will be, so color, image, and depth will be aligned. So the program is now running. That's the program. So I'm going here in camera driver, and I will click here to request for this alignment between color and depth. So at this point, I have the map. That's the map. I have the image of the camera. So this map is the map of the environment. This is being computed all the time, and this stops because now this camera that was seeing the depth directly from Kinect is receiving in another topic of ROS. So my launch file launches RVs as well. So RVs is configured to show everything, the map and the coordinate systems. Before going to the map, one extra window that opens is the object detection window. It's pretty slow at the moment. I have to work on that to make the detection faster. So here it's upside down. So if we click it, wait a little bit, because it takes time to get control of the window. If I run like that, I'm going to see the object and superimposed to the object detected. So there it is. So we have the bag. The bag is here in the 3D map. We'll see the bag, the image captured by Kinect. That's my hand. It doesn't go to the map because the map doesn't like to change. So it's a map that tends to be stable after the first map construction. And here you see everything together. So let's go down here to see the TF frames. Those are the most important thing that I'd like to show. So first of all, I'm going to remove the frames that are not necessary. So let's check here the name of those frames that are not necessary. So I don't need this depth frame. I need the depth optical frame. So it's the optical frame of the camera. I don't need this link. Neither these, because I need the optical frame of the camera. And the reminders of the frames I need. So let's go have a look in how the machine is seeing the environment. So that's how the machine is seeing the environment at the moment. So the environment is the coordinate system of the environment is fixed on the map. So, and what is the map? Map is a 3D structure. It's a 3D structure in a cube. So these two coordinate systems are the coordinate system of the depth camera of Kinect and the RGB camera of Kinect. So they are side by side in Kinect, these two cameras, and they define, when I start up the system, the 000 of my world. So the 000 of my world is here and is defined by a cube of 1 meter by 1 meter by 1 meter in size. So the X, Y, Z are defined by color. So we have red for X, G for Y, and blue for Z, for RGB, X, Y, Z. So this is the origin of the cube. The cube that my map is monitoring, actually my map creates a map of the environment, 3D map of the environment from the Kinect. So that's the origin of the system. But as soon as my system starts, I move the camera, or that is the Kinect itself, to that position. So I'm observing this cube a little bit behind it, and so that I can see most of this cube with the Kinect. And from this vantage point, I construct the 3D map. So this vector here, this vector shows the translation from the origin to this vantage point of the camera, and this other vector shows the translation from the current position of the detector object to the Kinect. So the position of the object is given with respect to the camera of Kinect, not the initial position, but that position of the camera that I call the localization position. So the camera is being localized by the mapper as being in that position. Okay, so if I move the object in the image, so you're going to see here my hand moving the object. So I'm going to move the object a little bit. If I move the object, you're going to see after some time, because the object detection system takes some time to run, you're going to see the position of the object being moved in the environment, by being detected as moved by my object detection system. So I'm going to move the object again. So you're going to see the detection of the object will be detected in another position, more to that direction, because I move to that direction, the object I move in that direction. So now you see the object being detected in this new position. The map doesn't change. My mapper interprets this movement as a movement of something that is actually moving. So it removes things that move from the map. So it's going to remove the previous representation of this object from the map. It's a bit slow at the moment because I need a more powerful machine to do these transforms in the map more quickly. So if you go back to the object detection screen, as it's shown here. So my coordinate system, the 000 is the position, that position in the cube. The 000, y grows down, x grows to my right, and z grows to in the depth, away from the camera. So I have also the localization system. So this tells me where the camera is. So I'm going to pick up Kinect with my hand very slowly, and I'm going to move it to in the direction of X. So if I move in that direction, you're going to see that I can localize Kinect with respect to the map. Okay, I have to move it slowly, otherwise my mapper will break down. So if I turn a little bit, you're gonna see that I can see the orientation as well. So currently we have mapping, object localization, and localization of the camera. At this point in time, the map was rebuilt, so I don't know exactly why, but it was rebuilt. So again, I have the representation of the object in the map, and it's being correctly detected here, as you can see. The exact orientation of the object, I still don't have it. I need to work on the exact orientation of the object. So I'm using the same orientation of the camera. So I'll work more to get the precise 3D, 6D position of the, I have X, Y, Z, but I don't have the angles yet. So that's it. I hope you have enjoyed this film.